All right, section 5.3. We continue to talk about this as we continue to talk about chemistry and chemistry reactions as kind of making a recipe. Well, when you make a recipe, you have half a cup or a quarter cup or a teaspoon or a tablespoon of something, and you have to be able to measure exactly how much you do that. So how do scientists and how do chemists measure how much of a substance they have? We're going to use a funky word called moles. What the heck is a mole? Well, that's just the unit we use to measure chemical substances. So in your baking, you use cups or teaspoons or tablespoons. Chemists use moles. Now, what is a mole? A mole is equal to two things, and this is a key. 1 mole of any substance, 1 mole of any substance contains 6.02 times 10 to the 23rd particles. 1 mole of any substance. 1 mole of water has 6.02 times 10 to the 23rd atoms or molecules. 1 mole of copper has 6.02 times 10 to the 23rd atoms. 1 mole of eggs, doesn't matter what we talk about, 1 mole of eggs has 6.02 times 10 to the 23rd molecules. 1 mole of water has 6.002 times 10 to the 23rd. Get my point? 1 mole of anything is equal to 6.02 times 10 to the 23rd. So 1 mole equals that. 1 mole also equals the molar mass of the compound. And each compound weighs differently, and we're going to figure out how to do that. So, right. Now, this 6.02 times 10 to the 23rd is recognized as Avogadro's number, not avocados. We're not talking about guacamole. We're talking about Avogadro's, not avocados. So Avogadro's number is 6.02 times 10 to the 23rd. That tells us how many atoms or molecules are in a mole of something. Now, I talked about 1 mole is equal to Avogadro's number, the 6.02 times 10 to the 23rd, or it's equal to the molar mass. And what is the molar mass? The molar mass is how much a compound weighs. Well, how much does a compound weigh? We're going to use the element's mass off of the periodic table. So if we do a very simple example like carbon, and you might want to get out your green periodic table as you're watching here. Carbon, if you look on the periodic table, what's the weight of carbon? Remember, that's the number at the bottom. The weight of carbon is 12.01. Therefore, a mole of carbon, or the molar mass of carbon, is 12.01 grams. All right. If we get a little more complicated here, we can take water. All right. What do we have in water? We have 2 hydrogens. Well, hydrogen weighs 1.01. So 2 times 1.01 plus the weight of oxygen. We add in the weight of oxygen is 16. 2 times 1.01 plus 16 gives us 18. A mole of water, or a molar mass of water, is 18.0 grams. So we are going to focus a little bit on molar mass. So how do we go back and forth between mole mass conversions? Well, what I want us to focus on is that's practice figuring out the molar mass of a couple compounds. So let's just start with table salt, NaCl. The easiest thing to do when you're figuring out the mass of compounds is figure out what elements you have. So what elements do we have in NaCl? We have Na, we have Cl. All right. Next up, how many NAs do we have? We have 1. Now looking at the periodic table, what is the weight of sodium? If you look on the periodic table, it's 22.99. What's 1 times 22.99? 22.99. Cl. How many Cl's do we have? 1. Times the weight of Cl. What's the weight of Cl on the periodic table? 35.45. 1 times 35.45 is 35.45. We're going to add these up. And when we add these up, we're going to get 58.44. NaCl weighs 58.44 grams per mole. And that's kind of our key unit here, grams per mole. The molar mass of NaCl is 58.44 grams. Now, if we go back, let's do a little more difficult example. Let's do, what should we do? Oh, let's do a tricky one here. Let's go CaNO3 2. Now, what atoms do we have at play here? We have calcium, we have nitrogen, and we have oxygen. Now, how many calciums do we have in this problem? We have 1. So we're going to go 1 times the weight of calcium, which on the periodic table is 40.08. 1 times 40.08 is 40.08. Next up, how many total nitrogens do we have? We have 2. Remember, parentheses mean to multiply. So we have 1 here times 2. 1 times 2 is 2. 2 times the weight of nitrogen, which is 14.01, is 28.02. Then lastly, how many oxygens do we have? This is kind of a tricky one. How many oxygens do we have? We have 3 times 2, so we have 6 total oxygens. 6 times 16, the weight of oxygen is 16, is going to be 80. No, that's wrong. It's going to be 94. Nope, 96, sorry. So we're going to take this, we're going to add this all up, and when we do that, our total is going to be 164.01. What's our unit for that? As always, it's grams per mole. Now, we might talk about in class going from moles to grams, or grams to moles. Well, how are you going to do that? Well, I might ask you how many moles is 80 grams of a substance, and all you have to do there is divide. So if you get a question like, let's go through a question here real quick. If you get a question like, how much does 0.5 moles of water equals how many grams? All right, you might have to do that. Well, first you're going to have to figure out the weight of water. So we have H2O. And in H2O we have H and O. And we already did this off the last slide. We figured out we have 2 oxygens at 1.01. So 1.01 times 2 is 2.02. We have 1 oxygen. The weight of oxygen is 16. 16.00 equals 16. Add that up, we get 18.02. If I want to figure out how much 0.5 moles weigh, I'm going to take 18.02 times 0.500 moles. I'm going to get 9.01 grams. You could do it the other way as well, and that's what we're going to kind of continue to practice tomorrow in class, is the idea of counting molar mass, being able to figure out molar mass, and then going back and forth between moles and grams. So moles is how much something weighs. Remember, a mole is our unit of measurement, and a mole is equal to 6.02 times 10 to the 23rd atoms, or the molar mass of the substance. This is Mr. Clinard, and I'm signing off.